Okay, got it. All right. So, so on the quiz, obviously the quiz is 8485, and we might start with something like 7x plus 3 over 8x squared. And we certainly, if we have monomials, we still need an LCD. Here we've got 1, we have 8. 8 is our LCD for the coefficient, and then x, highest power squared, is the coefficient. Sorry, is the x. Let me get J in here. All right, squared is the highest exponent, so there's our LCD. So in order to perform the indicated operation, keep in mind, for section 8.4, we were not multiplying by an LCD. We were rewriting equations. So 8x squared for both of these. Since this one is already 8x squared, 3 will be its numerator. It won't change at all. And then since this one needs to be multiplied by 8 and by an additional x in order to become 8x squared, we'll multiply 7 times 8x squared and get 56x. And then we'll combine our like terms, 56x plus 3 at the top, and 8x plus 8x is 8x squared. Only one denominator at the bottom. Now we could look and see, can we factor an x out of here to cancel? No, no x's can be factored. Can we factor a 3 out? And that cannot be factored out either. So this would be our final answer. So just remember, when you have an equation, you can multiply through by an LCD. But when it doesn't have the equal sign, you would have to rewrite in terms of that denominator. Hi, Jay. Thanks for joining us today. I'm just running through the quiz. You guys took the practice quiz. So if you did well on the practice quiz and you take good notes, the quiz should be pretty much the same thing. Every once in a while, there's a twist or a turn or a different sign, but it should be very, very similar. So as I was reminding you last week, and let's see, I got Sam coming in too. As I was saying last week during our Zoom conferences, that when you have expressions, you just have to watch out that you're not multiplying it through by an LCD unless you have an equation. So now here's our next one. We have 7 over x plus 6 minus 6x over x squared minus 36. So our first step is always to make sure, hi Sam, is always to factor. So this is x plus 6, x minus 6, because at this point we know this is a difference of 2 squares. It factors into our conjugates. We have a same factor. So our LCD, we have x plus 6, and we have an x minus 6. Remember, the LCD only has a square if one of these has a square. Neither one has a square. So it doesn't matter that there are 2 of them. We're not counting them up. We're looking at no exponent, or exponent of 1 here, exponent of 1 here. So the highest exponent for x plus 6 is exponent of 1. So that's our LCD on the left. And on the right, we have subtraction. Since this one is the same, this stays the same. Over here, x plus 6. We have x plus 6, but we don't have x minus 6, so that's what we would multiply by. And so now 7 times that multiple, 7 times x minus 6. So that would be 7x minus 42 minus 6x all over x plus 6, x minus 6. Obviously, 7x minus 6x gives us 1x. So I'm going to simplify like I can on a board without having to write it again. And we have x minus 42 over x plus 6, x minus 6. And nothing else can be simplified because this binomial does not appear down here, so it cannot be canceled. These binomials don't appear up here, so they cannot be canceled either. So they're finished. All right, moving on to everybody's favorite. What if you have denominators or binomials that are backwards? Okay. So here we have h minus x, h minus 8, and here we have 8 minus h. All right. So we can flip this. We can flip it over if we do that. But then it creates this awkward double sign thing. So we can combine these two signs. Remember, a positive times a negative is a negative. So instead of writing plus a negative, one sign, okay? One sign there. So that negative, instead of being down here, would go out front. It would cancel out that positive. And now we're ready to combine our like terms. We have h minus x at the bottom. 6 minus 6 is 0 at the top. And anytime the numerator is 0, then that means that the number is 0. If the denominator was 0, it would be undefined. But if the numerator is 0, it is 0. So be careful. Don't choose no solution or no answer. There is one. Okay. Now, as far as being undefined, remember, h can't be 8 because that would make it undefined. And that's what happened in a couple of problems in section 8.5 when you're solving. You have to watch out for those undefined numbers. All right, next one up. What do? We have a whole number. And we're adding or subtracting with expressions. Well, we still need our LCD. This denominator is 1, so our LCD is x minus 3. And when we already have x minus 3, then this stays the same. But here we had 1. So if we had to multiply by x minus 3 to get that denominator, we have to multiply 8 by x minus 3 to get that numerator. Luckily, it's a positive out front. If it was a negative, I would be multiplying through by a negative 8, but it's a positive, so we multiply through. 7 plus 8x, and then negative 8 times 3, 24, over x minus 3. Well, 8x, we don't have any other x's. Negative 24 plus 7 gives us negative 17. And that'll go away. So there's our answer. Once we combine those like terms, there's nothing we can cancel at the top or bottom because there's no matching binomial down here, 8x minus 17, and there's no x minus 3 at the numerator either. So that would stay exactly as is. All right. See what we've got here. Okay, so finally, one with a little bit of subtraction. So we got to watch out for our sign there. 9x over x plus 5 minus 7x minus 10 over x plus 5. So we have to watch out for that negative sign. We have to distribute it all the way through. So 9, we have at least, we don't need a least common denominator because we have a common denominator of x plus 5. So now 9x minus 7x plus, because we're distributing both, plus 10. So 9 plus 10, we end up with a negative 7x plus 19 over x plus 5. And it shouldn't be any issue, this or negative 7x minus 19 over x plus 5. These are equivalent. These are equivalent. So it wouldn't be an issue. if you happen to put 19 minus 7x over x plus 5, that should also work. My math lab, the one that I've got in front of me, I'm surprised you guys didn't type in and go, Ms. Summer, you made a mistake. I apologize. I just realized I did not copy the x from the 9x. So I'll try to keep my mistakes to a minimum today. So we had 9x minus 7x plus 10. So that would give us 2x plus 10 over x plus 5, which would be factorable in the numerator. And the x plus 5 would cancel. And that would give me a 2. So that's even easier, so much easier to type in that value. Okay. Moving on without mistakes. Okay. All right, so let's take a look at another subtraction problem and another problem where the denominator is twisted around a little bit. Okay, so in order to change that, watch, I'm not going to write it again this time. I'm going to change the order, which means that that would be negative. However, I've got a double negative, so I'm going to change it to positive. So once again, I flipped it, brought the negative forward, which made the other negative end up being a positive, double negative, positive. Okay, so hopefully that made sense. So now we got 4 minus 5x over 8 plus 1, or 9 over 4 minus 5x. Now, some of you might say, well, can I flip this one? Yes, you can. So let's go and do that. Back to the beginning and see what you get. You might say, well, what if I flipped this? Okay, negative 5x minus 4. So this negative would not be down here, it would be out front or with an 8. So we would have negative 8 minus 1 over 5x minus 4. So we'd end up with a, let's see how we could do this equivalent. We'd end up with a negative 9 over 5x minus 4, which is actually equivalent. I'm not sure if my math level, they only gave me one answer on the answer key, but this is an equivalent version if you flipped that number. It's more typical to flip the second one, but I know that a lot of times we put the x value first. So if my math lab would count that incorrectly, I would look at it and go, oh, that's an equivalent version, not a problem whatsoever. Okay, but I know you want to see my math lab give you the correct score the first time. Okay, moving on. Let's do one that's got a couple different parts to the LCD here. So we've got an LCD that has 7, W, and W minus 1. Why do we take that W and that W? Well, because W is a factor and W minus 1 is a binomial factor. It can't be separated. So these aren't the same thing, right? If W happened to be 12, then this would be 11, one less. So they're not the same number. So we've got one of each, 7, W, and W minus 1. Here, we already have 7 times W. We don't have W minus 1. So we need 5 times W minus 1 for the top. At the bottom here, we've got W minus 1, but we don't have 7W. So now we're going to multiply that 8 times 7W. So in the numerator, we get 5W minus 5, negative 8 times 7, 56W. To make sure I didn't leave any of my variables behind this time. All over 7W times W minus 1. Yes, we can combine like terms. We have 5W and minus 56W. Those both have W's. If we take 5 of them away from there, we end up with negative 51 W. And I was just double checking. Yes. Okay. This was supposed to be an addition problem, but I made it a subtraction problem. It looks a little messy at the end, but that's what it would be as a subtraction problem. All right. No problems there. Okay. Moving on to another. Finally, let's get to some trinomials. We have a trinomial here. Not only is it a trinomial, it's a perfect square trinomial, which means that when you factor it out, you get exactly the same binomial. Now, keep in mind, when you write your LCD, you have to consider that this is x plus 2 squared. It is the same value twice, which changes your LCD because it has to be the highest exponent. So if you only wrote x plus 2 down here, then you would miss out that it would not be your LCD. Here, this is already the LCD, so this is just 19. Here, we have one x plus 2, we need the other one. So 2 gets multiplied by x plus 2. Luckily, in this case, it's addition, so we don't have to worry about distributing a negative. We have 19 plus 2x plus 4 over x plus 2 squared. We know that we have 19 and 4, which is 23. So I'll go and put that as plus 23. And there's nothing that can be reduced there. So 2x plus 23 over x plus 2 squared would be your answer. Sam, you entered twice? Okay. I got your name twice. Okay. So, next one. Now we're going to switch gears. Well, that was all expressions. Now we're going to do equations. If anybody has a particular problem, feel free to type it into the chat or just tell me the number, okay? But I'm going to move on to section 8.5 and let's do some equations. So here we are rewriting the expressions in terms of a new LCD. Now we're going to be doing the process of multiplying through by an LCD and canceling out fractions. Okay, so starting with a simpler equation, because we know these can get rather long. And this is supposed to be an 8. Okay. So if you're looking for an LCD with a number, take the highest number and count by that until all the others go into it. Might take a couple of tries. Obviously, 8 and 16 don't go into 20. Do they go into 40? Well, 8 does, 16 does not. Do they go into 60? Probably not. I'm trying to remember what 16 will go into. Okay, 80 does work for all of those numbers. So you may have to try, keep counting by 20 until you get something that 8 goes into and 16 goes into. So bingo, 80 is the number. Now, to save a little space here, not have to write it again, we're going to multiply through by that 80 here. Move this over a little bit here and here. Every single term gets multiplied by 80. So here, 20 goes into 80 4 times. Here, 8 goes into 80 10 times. And here, 16 goes into 80. Oops, I forgot how many times that was. 80 divided by 16, 5 times. There we go. That makes sense. All right. So now we've got 4 times x. 10 times 17, x, 170x equals 5 times x. Okay, well, we sure do have a lot of x's in that one. So when we gather them all to one side, we get 174x minus 5x equals 0, and we get 169x equals 0. And when you divide by 169, you get 0. Now, I know that when students get 0 on an equation like this, they're like, ah, I think I did something wrong. Because 0 is weird. 0 is an answer that kind of feels wrong. Watch, just check. 0 over 20 plus 17 times 0 over 8 equals 0 over 16. Well, this is 0, and this is 0 too. So 0 plus 0 is equal to 0. Yeah, that does make sense that it would have to be 0. Okay, so if it doesn't feel right, and a lot of times a 0 doesn't feel right, then just try checking it. Because when you have zeros, it checks really easily if it's the right one. Okay. Let's move on to the next one. We've got z minus 8 over 3 equals z over 7. Now, I love these kind of questions because if you have a proportion, one fraction equal to another fraction, you can just cross multiply, not cross reduce. That's something different. That's for expressions. This is cross multiplication, so we can multiply 7 times z minus 8 and multiply 3 times z and that here. Now, why does it work? Well, imagine that you're getting your LCD. In this case, it would be 21. And you multiply both sides by the LCD. So going back to that other method, let's see. 3 goes into 21 how many times? Up 7 times. 7 times z minus 8. 7 goes into 21 how many times? Oh, it goes in 3 times. 3 times z. So what mathematicians realize is we don't have to do the LCD method when there are 2 proportions. When there's, I'm sorry, 1 proportion, 2 ratios. Now, if there was like plus something, if there was another expression there, couldn't do it. Okay, so it's limited to just 2 ratios. So now 7z. Keep wanting to write the z. Minus 56 is equal to 3z. Subtract that, 4z is equal to 56. And z, it goes in 14 times, which is your answer. And of course, you could plug that in and check it out. 14 minus 8 is 6, over 3 is 2, and 14 divided by 7 is 2. So that makes sense. All right, rolling on to another problem. Sorry, I lost my page. Let's see, you've got some problems with whole numbers. Let me go ahead and pick this one. All right. Now, could you add these two together? Yes. And that would be an appropriate strategy. So you could say, hey, this side is 3x plus 6 over x plus 6 equal to 4 over 1. I'm just going to cross multiply it now. You could do that, or you could multiply it all the way through by x plus 6, and it'll come out to the same thing. So now 1 times 3x plus 6 is 3x plus 6 equals x plus 4 times 4. Now, some of you might be tempted and see, can I factor out a 3 there? You can, but you don't want to, because at this point, we're actually multiplying things out, and then we'll combine the like terms, and the simplifying or factoring anything out will occur in the last steps. So now we've got 3x plus 6 equals 4x plus 24. Subtract the 3, we get x. Subtract the 24, we get minus 18, and we have our answer. All right, now that is similar to, but we can't solve this next one the same way. We're going to see a whole number here. Actually, we could kind of solve it the same way, but I'm going to do 2 methods here, just in case you're like, well, I think I have an easier way to do this. First way, oh, I think I changed variables on you. Yeah. The first one's supposed to be a y. So anytime we have a 1, we can replace it, remember, with the same LCD. We could replace this with y minus 7 over y minus 7. And the reason why I'm doing that is because I was just showing you the last one, we can turn into a cross multiplication problem. And we could do that here if we recognize that 1 is y minus 7 over y minus 7. Why do I pick y minus 7? Because that's the LCD. So I want them all the same. So now I could do ay plus y minus 7 over y minus 7 here, and 2 over y minus 7 here. And here, the 8 and the 1y, 9y. So yes, we can cross multiply here, and our problem would keep going. It would be fine. What are we going to get? Yeah, we're going to get a whole bunch of y squareds. So this strategy is probably not the better strategy. So I'm going to go back. You could continue, but it would be, well, actually, I'll just continue since I'm here. We've got binomials to multiply by, so 9y squared first, outer minus 63y, inner negative 7y, and last plus 49. Here we've got a monomial times that, 2y squared and negative 14y. So as you can see, it's getting a little bit messy because we have numbers that need to be multiplied, numbers that need to be factored, and we're going to end up, let's go ahead and do that. Just in case anyone picks this method, that'd probably be a good idea. And when we do this the second time, you're like, why didn't you do that the first time? So we are going to do this again, a simpler method. So if you're a little confused, don't worry about that. So negative here, negative 70y plus 49, but if we brought over that negative 14, this would change. We'd have to add 14 to it. Let's see, that would drop it down to 56. Negative 56y equals 0. And here we could factor out a 7. We would have, it's a long one. We would have 7 times y, 1 and 7, x, excuse me, that's a y. We would have 2 negatives, multiply to 7, add up to 8. And what we would end up with is that y could be 1 or y could be 7. Well, if you look at the original problem, y can't be 7. So y equals 1 would be our answer. Now you're probably saying, okay, you promised us an easier way to do this one, and yes. I did that by doing a common denominator problem. However, multiplying through by the LCD is going to be super easy compared to this. But if you get yourself into this, it's still okay, all right? Just remember that the 7 we threw out because it would be undefined. Now, let's do this in the easier method that I promised by multiplying through by our LCD. So let's change this back. The original problem we had, a 1. We know that that has a denominator of 1. So now we're going to multiply through by the LCD. Y minus 7, y minus 7, and y minus 7. Now here, cancels, cancels. So in this one we have a y. Here we have y minus 7 times 1, so plus y minus 7 equals 2y. We're like, wow, all that work that we did before, that multiplying by the LCD, that's a really great thing. It is. So now we just have 9y minus 2y from the other side equals, let me move the 7 over here, and we end up with 7y equals 7 and y equals 1. We didn't even have to throw out in another answer from that other one because we only got one answer. So this one is definitely vastly superior. So multiplying through by that LCD is really good. I almost regret going the other way with the other problem. But what happens sometimes in class, if we were in class, people ask for alternatives because if they go with an alternative, how do they get themselves finished with that problem? Now, here is one where cross multiplication is your best solution, because if you have an LCD of a minus 7 and a minus 9, you're going to get the same result, regardless of whether you do the multiply through by the LCD or cross multiply. So a times a minus 7. Here, a minus 9 times negative 8. Making sure that that's 9. Make sure that we distribute a squared minus 7a equals negative a times plus 72. You're like, that a squared's not going away, so we're going to have to factor, right? So we make sure everything goes to one side. A squared, add to 8 gives us a positive a, minus 72 equals 0. So watch your signs on this part, because sign errors are the biggest errors that I see. Factor it out. A, 8, 70, 8 and 9. Multiply to 72. Different signs. The highest one should be positive. So now a minus 8 could be 0. A plus 9 could be 0. So a could be 8. A could be negative 9. Well, let's check. A can't be 9, but it can be negative 9. That's fine. A can't be 7, but it can be 8. No problem. So our only restrictions would be 7 and 9. Here we've got 8 and negative 9. So both of those are in. We would have a double answer, 2 answers. All right, let me try to roll out a few more problems. Thanks for sticking with me. As I said, if there's something in particular, no one's typed in a number, so I presume everybody's just coming for a review, or you just want to hear the sound of my voice because you're used to it by now, especially for reviews. Okay, let me go ahead and bump it up to a problem that's got multiple steps, a lot of multiple steps, so I'll write a little bit smaller. Okay, so we have a trinomial that needs to be factored. We always make sure our denominators are all factored out. R are different signs, numbers that multiply to 6 and subtract to 6, 2 and 8. And I put the higher one, 8, so that I would get positive 6 when I combine and negative 16 when I multiply. Now, it is no coincidence that they're the same factors over here. So typically when you see other factors that are very similar or may be similar, that you want to try those out. Now, since we have x plus r plus 8 and r minus 2 is our factor, r minus 8, r plus 8, r minus 2, just slide it in here and here. I apologize for squishing it in there. So here they both cancel, and I have 2r minus 2. Here, r plus 8 cancels, and I have the 3 times r minus 2. Here I've got r minus 2 cancels, and I have r plus 8. So I need to do some solving. Okay, and some combining of like terms. And then bring everything to, bring the r's over here, bring the 8's over here, and divide. And it comes out to a nice lovely 4 that we could plug in and check if we wanted to get that far. Okay. I'm going to wrap it up with the problems that don't have many numbers, our favorites. We're still using the same method that we used here with our equations, because these are equations and we're solving for a particular variable. So if we have t equals 5u over b plus e, and we're solving for b. Solve for b. Well, b's in the denominator. How do we get it out of there? Well, we're going to multiply both sides by our LCD b plus e. Obviously, on this side, we're going to have to distribute. Here, it just cancels. So the good thing is it's in the numerator, at least. We've got t times b plus e here. And on this side, all we have is 5 and u. Now, we have to distribute it. We can't break the b away from the e without distributing. We got to get those parentheses gone. And we can definitely take this TE and move it. And we need the b by itself, so we're going to get rid of the t by dividing. So now here's our answer, 5u minus TE over t. And that t can't cancel with anything because there's no t by itself in the numerator. I know, these are fun. Yes, that was sarcasm. Okay. Next one up. C equals 660x over d squared. This time we're going to solve for the x. Luckily, the x is already in the numerator. So I'm going to multiply by the LCD d squared. So I get a d squared c equals 660x. And I just get rid of the 660 from both sides. That one cancels, so x is equal to And they might put the C first just because it's bigger, but it doesn't matter, C first or D squared first. You've got X by itself. All right, one final one, and this one could be a little tricky sometimes. We've got 1 over B plus 1 over 7 equals 1 over X. We have a different denominator for each, and we are looking for X. What is X? Solving for X. So our denominator is 7 times B times X. So 7BX here. Move that over a little bit. 7BX here. 7BX here. So here the B is going to cancel. The 7 is going to cancel. The X is going to cancel. So here we've got 7X plus BX times 1 is BX, and 7B times 1 is 7B. So we no longer have the fractions. We're moving in the right direction, but we're solving for X. We can't solve for 2 X's. We can solve for 1 X. And right now we have 2 X values. We don't know what B is, so we can't add it to the 7. Even though they're like terms, we can't add them. So what do? Factor out the X. And then we can get rid of this factor, 7 plus B, by dividing by it. And then X is equal to 7 times B over 7 plus B. And notice we can't cancel anything here because one's multiplication and one is addition. Okay, well, that is the end of my reviewing over the quiz. I did probably 75% of the problems. So you get a little bit of everything that you'll see in your quiz due tomorrow. And then we'll be reviewing for our test. Our test is going to be due Thursday this week. And you'll be happy to know that we're ending with radicals. Radicals usually take 1 or 2 steps, much shorter. So we're ending on a much easier topic for just like 4 or 5 more days. Okay. All right, guys, if you have a question, feel free to stick around and ask me that question or type it in, or you can go ahead and exit out of our meeting. See you again soon. Good luck.